All right, number 17, we have omitted due to time constraints. So we're going to go on to number 18. And number 18 wants us to use the definition of integral to evaluate. It says use the right Riemann sums and theorems. All right, so we have the function integral 0 to 4 of 2x plus 3 dx. Now, if we're going to use right Riemann sums, normally we need an n value. I don't see an n. So remember, we are going to be looking at the limit as the change in x goes to 0. So we'll use different values of n and see what it looks like. Due to this being a linear function, we could solve this pretty easily with geometry, and then we can just check with the Riemann sum to verify it. So 2x plus 3, we would go up 1, 2, 3. And then we would have a positive slope going up. And so this would stop at 4. So you have this trapezoid shape. And you have base 1, base 2, and then this distance here is 4. So if we plug in 0 to this function, 2 times 0 is 0, so we'll get a height of 3 here. If we were to plug in 4, 2 times 4 is 8. 8 plus 3 is 11. And so we have base 1, 3 plus 11 divided by 2 times the height of 4. This will give us 14. 14 divided by 2 is 7. 7 times 4 is 28. So using geometry, we can get there pretty quick. We're going to do Riemann sum. We're going to do the right sum. That's what we're asked to do. I'm going to just write it as I'm going to do it in the calculator. X equals 1 up to n. And I will do different values of n. I'll just do 3 of them. 10, 100, and 1,000. That's also going to change our change in x values. So I'll just plug that in. So our change in x will be 4 minus 0, which is 4. And we'll do 4 divided by 10, by 100, and by 1,000. And that'll give us our partitions, and we'll see how close we get to that 28 using the right Riemann sum. All right, so we will do our function evaluated at a plus, and it'll be the x value times the change in x. And then we multiply change in x again. So that's our summation notation. So from here, we're going to put this in the calculator. I don't think we have to restrict it, so I'm just going to type the function in 2x plus 3. Okay, you see the whole line, but I can restrict it. I'm going to go second quit. We're going to do sum x equals 1 up to 0. Sorry, this time we're going to do 10. We're going to recall our function, y bars. The wrong thing. Y bars. And then in parentheses, our lower limit was 0. 0 plus our x value. And that x value is going to get multiplied times, it's going to be 4 divided by 10 this time. And then on the outside, we're going to have an additional 4 divided by 10. All right, so when I compute this right Riemann sum, we get 29.6, which is pretty close to 28. But again, we want to take the limit. So I'm going to change this now to 100. So I'm going to do second enter. And I'm going to add a 0. When I add it to the end, I can just add it. Here I'm going to need to insert it so I don't mess up the formula. So I'm going to do second, insert a 0. And then I'm going to go all the way to the beginning, my upper limit. And I'm going to add a 0 here. Right. And so when we have 100, we get to 28.16. And I'm going to do it one more time. Second enter. I'm going to do 1,000. So if I did 1,000 little rectangles, how close do we get? Insert a 0, second, delete button, and add a 0. And then go to our top partition and just add another 0. All right, so we're going to compute this. And it's thinking, it's doing a lot. All right, so by the time we do 1,000, we can see that it's really close to 28.01. So when we round this answer, it looks like 28 would be our interval.